And
Omer ready?
I am ready, and action.
And action! Okay, so hello everyone. And today we're going to talk about security stuff. But what do I mean by security?
Security
Yeah.
stuff.
Security stuff. But what do I mean by that? So first we'll start with a simple question to Omer, because we like to start with questions to Omer. So Omer, I have a question. Can I ask a question, Omer, if you are here
Why
already?
don't you ask someone else? Why always
No,
me?
I want to
Why
ask
me?
you.
Okay.
Okay, so I'll ask you.
Yeah.
I was just wondering lately, I want to run my CI/CD runners. Remember we had a session about it, about CI/CD runners, but I don't want to put them in a private network. So why would I put my CI/CD in a private network, like behind a NAT gateway, if they can be in a public network and they can get their own public IP and then access external services directly, and it will be easier maybe even to SSH to my runners, publicly. So why do I need to put them in private network? I hate it. Why would I do that?
Well, you know me. I have annoying questions. So let's start with the why. Why would you want to put them in a public network? Is it what you said? Is it the access? Is it
Yeah,
something
because
else?
let's say my runners do a lot of sudo apt-get install, apt-get update, right? Like they run on Ubuntu, so they get a lot of packages.
Okay,
They do
makes
a lot
sense.
of so they lots of traffic from the external internet, from the public internet. Why would I want that traffic to go through a NAT gateway, through something that proxies the traffic and costs a lot of money? Why would I do that?
Okay, I'll try to divide it to two parts. The first one is if you're installing a lot of things every time a CI runner starts its way in life, feels like the process can be improved, and maybe you can either cache the things, burn them into the image or the container image, whatever you're running or building there. So it sounds weird to have a lot of apt or apk or whatever type of packages you're running being installed every time it starts running. So maybe you don't even have to get out to the internet, and maybe you
But
don't
that's
have
my
to
use
use
case. That's what I have. Trying to help a client, he can change it. That's the use
Fine.
case.
Okay, makes sense. So
Need to fight it.
makes sense. I get it. So I would still use a NAT and simply I like to keep this rule of thumb of deploying everything in a private subnet. Anything that doesn't have to be very specifically public, like an out-facing load balancer or some kind of, types of CloudFront, or maybe it's some kind of a VPN or a gateway that you need access from the public network. I would keep everything in private. And why? Because every time you expose something, it's an attack vector of some kind. There are scanners running on the internet every day, every second, all the time. Scanners of ports, addresses, openings of any sort, shape, or kind. If you're running something public, probably at some point it'll expose something that it shouldn't. It doesn't have to be because of you. Maybe it has some kind of vulnerability. Maybe it has some kind of opening. Even if you're running Nginx, maybe someone found a vulnerability in Nginx, and for some reason you used this very specific feature that wasn't patched yet, and you're exposed. Doesn't always have to be like this 0-day horrible attack. It can be small stuff, but you can get hurt. So I try to keep everything privately exactly for that reason. If you're running a CI runner, for example me, I'm running the GitLab runners. That's just a simple Docker machine that GitLab built on top a few of their automation stuff to connect it to the cluster as node that can take up work. And I have no idea what's going on with it. Maybe there are vulnerabilities. Maybe it shouldn't open certain ports. Maybe it shouldn't be accessible from other workloads. At the end of the day, that's what it does. It's waiting for workload to take and do stuff in the cloud. So not only it can be accessed from the external world if I expose it, it more often than not has roles to do pretty much anything it wants in my account, right? If it's running in my AWS account, for me at least, that's my case, it can do pretty much anything. It deploys to Kubernetes, to ECS, it sets up Lambdas instances, it's going to secrets managers to fetch up parameters and
Remember
secrets.
that we have this, everything that we have a question for, we're like, everything we answer is like, it depends, right? So now I want to add like another thing, like what if, okay? So instead of it depends, let's say I'm saying now what if? And what if I'm super responsible and my CI/CD runners are protected behind an AWS security group, and I also took care even of the NACLs, the network access control list. I even took care of that, even though it's very extreme, so I blocked everything, and I'm very, very responsible to block anything that shouldn't access the runners. And you know what? I don't have any inbound access except for specific ports that from specific maybe security groups or specific, very, very specific IP addresses. Everything is very, very, very specific.
Yes.
So I'm protected behind AWS's network. Why would I also need to put everything behind a private subnet? Isn't it like a big overhead?
No, and it's a great question. And exactly because of the reason that it's not always up to you. You can be the best engineer in the world and keep everything closed, but you're not working in an isolated environment. You have fellow engineers, colleagues, I don't know what. Someone might put an instance. Maybe they don't know what they're doing, so they use the same security group that you set up very nicely for your machine, and you're now sharing it. And for some reason, they've opened another port. And that port, somehow, someone managed to get a reverse shell from their own local machine into that instance. And since it's under the same security group, they can access your CI runner. And I'm going to kind of harden my claim, the one I said earlier. CI runner is one of the most sensitive components you have in your workload, simply because it deploys everything. And for the deployment, it needs to access everything. It needs to access all the environments, or hopefully you have CI runners segregated between environments.
It also has your source code, because it does git clone.
Exactly, the source code, the images, the secrets, parameters, permissions. I mean, more often than not, you'd want that actually to have more permissions than power users or actual engineers in your system, because that's the component that you want to be the one deploying stuff. So I'd keep not only CI runners, by the way, I'd keep everything, but CI runners specifically, I'd keep behind the network. Now, because you mentioned, do you want to have like 2-3 minutes, a quick run on what's a public network, a private network, what's a VPC in Amazon?
Yes,
or
I do.
In any cloud.
I do, but before that, I think we can sum up like regarding the CI/CD runners. I think it's a great tip that keep your CI/CD runners safe, because you never know who can access them. So
by safe, by the way, not only not accessible, patched, updated, rotated, like we talked last week. Their cache should be cleaned from time to time. People who hack your systems, one of their methods of work is leaving some kind of backdoor, because they expect that the opening is going to be closed, and they need to set up something around that you hopefully won't find them, and they leave some kind of backdoor, and then they step out, wait for everything to come down, and then they come back. That's what they usually do, like on a large scale. If you rotate your systems, you probably avoid stuff like that. So even if you did open something and you are keeping everything rotated on a schedule, you're probably safer than when you're not doing it.
Okay, sounds good. So let's go over. We talked about private, public, VPC. So go ahead, do your thing. Tell us about the VPC and private public network.
My thing. Okay, to whoever's listening to this, kind of a rant. This is one of the most...
Whoever it may concern, whomever.
Yeah,
whatever.
One of the most basic interview questions. I always ask that. So here I am sharing an interview question. I'm asking people, please tell me, how would you build a VPC for a very simple application, regardless of the components now? Just build a VPC and explain to me what's going on. A lot of times, candidates just don't say enough. Hopefully they're saying the right things, but they don't say enough. And by enough, I mean this. Usually, in the past, you didn't have to create a VPC. There was this EC2 classic thing. You can run it out in the wild, kind of like Lambdas today, and it would just run without the network somewhere. I don't even remember how it worked. It was so long ago. Yeah. I don't think that's an option anymore. You now have to run an EC2 inside a VPC. A VPC is an isolated network, right? A virtual private cloud. There's a synonymous components in every other cloud provider. That's the network. The network, the fact that something's running in a VPC doesn't mean that it doesn't have access to the internet, or does have. It's just a network. You now have to segregate it with subnets. Subnets are probably spanning across one availability zone, and a subnet can either be public, it can be private, and kind of the third type is being private but have access externally. What do I mean by that? You can put, like you said, exactly a NAT gateway or a NAT of your own, whatever. You can use a NAT. And a NAT, what it does, it takes the external traffic, distributes it internally with different IP addresses. And then what you get is you can, as a backend component, I can access the world. I can go do apt install something and fetch the package. But if someone tries to access me, they really can't, because the external component is the NAT itself. So people can access the NAT, but they don't know how to get past the NAT and reach the private IP. They can't because it's a private one. So that's the thing. And then what I talked earlier is a complete private subnet. You have a subnet that doesn't have a NAT, doesn't have an internet gateway, and it's just nothing can come in or out except for what you allow in the security group. So that would be probably something you use for databases, secret manager, private components. Okay. Now, the difference between a private one and a public one is not some kind of configuration. It's a route table. On AWS, at least, you have different kind of routes for each subnet. If your subnet has routes from an internet gateway, this means the outside world can access whatever you put there. Regardless of whether you allow public IPs, don't allow public IPs, it does matter, but it doesn't matter in the let's say bird's eye view. Okay, it is a public network as long as there is some kind of routing allowing access from the outside. And the difference with a private one is that there's no such routing. The routing only allows either a NAT gateway or nothing else except whatever security group is set on top. That's what I really care about when people explain to me how a VPC is built. And now the important
Let's
stuff.
zoom on the route just to be even more specific, because we like to be specific.
Yeah.
When you say public, we just mean 0000/0, so it means like to any public IP address, right? That the route will go through internet gateway, which that means this is a public subnet. And the other option for private network is that it will go through the same IP, the 0000/0 will go through the NAT gateway. So that's a private
Everything
network.
is either routed outside, routed through a NAT gateway, or routed internally. Exactly. Yeah. And now the other layer, the next layer other, is the security groups. And security groups are what allows access from somewhere else. I can protect everything under this security group by setting up rules, whether you can access by port 22 for SSH, where from, whether you can access only the port for my Postgres database, whatever it is. And now what's important to say is when we have a public network, people can access only based on what the security group allows. So, for example, if I have a load balancer, and that's part of my interview question, if I have a load balancer sitting in a public network, how do I protect it? So you tell me you put a security group. I say, okay, good, nice, we have a security group, but what's allowed? And now you start getting into what's allowed. So you probably want to have only port 443, right? For HTTPS, you probably want to have a certificate that helps you encrypt and decrypt whatever incoming traffic or outbound traffic is going.
You also want port 80 for HTTP to redirect the traffic to HTTPS, right? I assume.
Very much depends. You either want that or to redirect. Be careful not to not redirect and just leave openings for port 80, because then you might be sending in and out traffic that's not encrypted. But yeah, you probably don't want to open it to the entire world or across all TCP ports or, other shenanigans we know. That's the basics, okay? There's a lot more, but that's the basics of a VPC network, what's public, what's private, and how to protect it.
Okay.
That's my small rant.
Okay, so I have a question. It might be a tricky one. So if you don't know the answer, that's okay. I only found out the answer after, a trial and error, okay? Mostly error. So I have a question like this regarding security groups, maybe to enrich our audience with more knowledge, all right? So let's say I just SSH'd to an EC2 instance, which is like on a public subnet. I can reach its IP, okay? Don't, let's not mind the private public right now. Just talking about security groups, okay, and how they work. So I SSH to a security group, through port 22. Everything is allowed properly, and I'm in, I can write, I'm in the terminal, I can SSH. Do you know what happens if while I'm in the SSHing to the security group, and I remove, let's say I remove the rule that allowed me initially to SSH to a security group. Will my connection, will it disconnect, or will I stay connected?
I'm pretty sure it won't get disconnected.
Why? You are right. First of all, you are right. I said it's a trick one. I want to trick it even more. Why wouldn't you get disconnected? You know that?
Because the SSH, when you limit a security group, when you put a rule, the rule applies to the initiation of a process, of an authentication process.
Yes.
If the rule is there or not there when you're already connected, the tunnel has already been created.
Yeah, and that's all. That applies not to SSH. That applies to any. You know, I just took SSH because it's more common and people can more relate to that example. But it's important to realize that security groups apply only for the initiation of a connection. So in case you're already having a connection, then turning off the security group rule, or and restricting it even more. So you should know, and Omer, you already know, but the audience should know that the connection will remain until you try to connect again. So it's like it's allowed for infinity until it's disconnected for even a split second. Okay, so that's the rule about security groups, all right? Let's talk about network access lists, access control lists. Like, usually people hear about that. So I think we'll also we'll finish this session talking about maybe the small difference between the two and when to use this and when to use that. Okay, what do you say? Sounds good?
Sounds perfect.
Okay, so go ahead. Like, can you just say in a few words what's in network access control list?
So a network access control list, or a NACL in short, is your way of blocking everything on the VPC level, on your network level. Honestly, I rarely use it. Rarely to never use it. I think most of the people do. The 1 or 2 times I did is, I don't even remember if it was a real DDoS attack, but it was a suspected, or at least DOS attack. And we just blocked a range of IPs. You can guess the country. I won't shame them here.
No.
Russia, okay. And we had to block a range of addresses, and that was a very easy way. Instead, you probably don't want to go through each and every security group in your account or multi-account organization and do it. So a NACL is an easy way to block it. That was my 1 and only, or 2 and only times I've used it.
So let's have a rule of thumb for security groups and NACLs. I'd say security group is for allowing connections, and NACLs is for blocking connections, and maybe even we can say malicious connections, because usually we don't really touch NACLs. Okay, I say you and I, Omer. I don't know who else use it, but usually you block it. But if you want to allow connections, inbound connections, outbound connections, you should use security groups, because they're not allowed by default.
It has another use where sometimes you have like hardening network policies. For example, I do not allow in my company, let's pick a port, telnet port. I can't remember, what is it? 40 something, 20 something.
Wow, I don't
21
remember.
Is FTP, 24 maybe, whatever, FTP, let's say FTP. Okay, 21.
Okay.
I, across the board, will prevent FTP connections, will block the FTP port on a NACL, because I don't care if you want to allow it through a security group. I just declare it across the board on my VPC. That's another use.
And also about that, so I like it that if you block it in the inbound, it also applies to the outbound, right? So a NACL, it's like if you decide from one side that it's not allowed, the other side won't be allowed anyway, right? It
As
blocks
opposed
the whole
to a
connection.
security group where you have inbound and outbound connections.
Yeah, so a security group, when you allow an inbound, so maybe someone can access you, but then you can also access it back,
Yeah.
And if in a NACL, if you don't declare it on both sides, it will get blocked. So they work a bit differently. In NACLs, you need to take care of both of the sides, of the rules. And security groups are like, you can take care of only one side. And it's called like stateful and stateless. I don't really remember which is which. I think stateful is like a security group, maybe?
I think the stateful is a security group for the reason that it has rules. Rules are, I think, the state. That's what you call a stateful rule system.
Okay,
I think.
Makes sense.
Yeah.
In a sense. So I think that summed it up a bit. I don't think we even need to do a summary. I think we're clear and good. Anything else you want to add? Maybe.
On that front, no. I think I'm good.
Okay, so I think we had enough for today.
Okay, but wait, before we finish up.
Yeah.
What cool thing have you seen this week? If you did.
So you remember I told you about Carpenter and GitHub Actions?
Yep.
So I had to do some automation that scales like crazy. Let's say run 200 jobs in a single pipeline.
Okay.
So I actually, the GitHub Actions runner controller and Carpenter work like crazy. And I found out the limits of GitHub Actions where you can only run a matrix of GitHub Actions. You can only run 256 jobs per matrix. I didn't know that. So there you go.
Gotta love limitations of SaaS services and getting to them. Yes.
Yeah, it's nice. So what did you learn this week?
So I've seen a blog post. It's actually a pair of blog posts. It's not very much new. We will share it in the description. And they speak about setting pods limits and limits and requests for resources that are mainly CPU and memory, because that's what you normally set. And it has this great analogy, which I loved. And I'll just give the TLDR. Okay. When you set a CPU for your pods, you never want to set a limit. You always want to set the request. And the reason is, basically, I'm just letting you know, but I really suggest you go read the article. Sorry. A CPU is a compressible unit of resource, meaning whatever you request, you get. But if you don't set a capacity and for some reason you try to scale up and there is some kind of free CPU, you're not hurting other pods. You're just taking something free resource that's already in the node that you can consume. And the analogy is two friends walking in the desert. Sorry, I have to drink some water.
Go ahead.
Because that's the analogy. The analogy is water, by the way.
Okay, so commercial song for now.
It's two friends in the desert with 2 liters of water. Each one has a bottle of liter of water, and he compares that to a CPU. So you drink your 1 liter of water because that's already yours, but you don't have a capacity. And if there's a third bottle and you've set your limit, you got to the capacity of 1 liter, there is a free bottle, but you can't use it because you have a capacity. As opposed to having this liter, but you're now sick and you really need a little bit of more CPU, you get it. And now we're moving on to the memory. And memory is a non-compressible unit of resource. It's just it. And the analogy is what happens if you and a friend are sitting at home and ordering a pizza. You want 4 slices and they want 4 slices. If you set a request but don't set a limit, your friend, which can be a little bit chubby, can start eating a little bit of the pieces you own, right? Something you ordered 4 slices and he ordered yours, and you can just keep eating out of your pizza. Yeah. And then you, Mr. Process, are left with no slices, not enough slices to run. So memory is compared to pizza in that sense. And you want to set your limits and your requests exactly the same. No more, no less.
Okay.
That's it.
Sounds cool.
Yeah, I'll share the blog post. Really nice.
Yeah,
really
I want to see that.
I'll show you. I promise.
Okay. So, again, thank you, Omer. Thank you, everyone, even though no one is here.
Yeah.
Bye.
Bye-bye. Stopped it.